Alright, it's November 21st, 2020, 12:32 p.m. I finished wiring up the Chamber of Doom LED plate to run each individual LED off of its own Luxdrive Minipuck buck converter. It's pretty darn small, so feasible to enclose it all in the helmet. And I've made a fixture with one LED in it to test this thing out to make sure it doesn't let the amperage run amok. So what I've got hooked up here is the fluke to monitor the amps, this thing to monitor the voltage that's going into it, and then a temperature probe clipped to it to see if it's getting way hot, and then this power supply, got it set for 12.2 volts right now, and I got to check it later at the same voltage these are putting out. And I also got this here to run that little fan. Alright, putting out a pretty good breeze there. Alright, I'm going to turn off the light so that you can see the LED, ultraviolet LED working. This ungodly tangle of wires here is hopefully hooked up correctly, and all to do is touch that, and then let's see what happens. We put this into the tripod. Alright, here we go. Well, that's interesting. It's at 5.85 volts. And 357 milliamps. The temperature is going up. I wish I could directly measure the temperature inside the LED, but obviously that's would be kind of tricky. Well, that's interesting. It's drawing 0.19 amps. That doesn't seem correct. Well, I guess it is, because it's only 5.79 volts. So it's, yeah, like half of what the output voltage is. So it seems to be pretty efficient. If it's 12 volts in and 0.19 amps in, and then less than double what the input amperage is going into the LED, and then less than half the voltage. I mean, it's running pretty efficiently. The Minipuck. Here. That shield there is polycarbonate to stop the ultraviolet from getting to my eyes and skin. Yeah, it'll be interesting to see where the temperature stabilizes at. It should reach some point and then just stay there. And 91 degrees is not bad at all. But then again, who knows, it could be twice as high, 3 times as high, 4 times as high, I don't know, inside the LED itself. The forward voltage on the LEDs is supposed to be 6.5. That's the minimum. And they can supposedly go up to 8, or 0.8 amps, 800 milliamps. They can supposedly go up to these particular ultraviolet C LEDs. So I should be well within its operating range here. I don't know how high the voltage would have to be for it to be at that high. The Minipuck is available in 3 amperages, 350 milliamps, 500 milliamps, and 700 milliamps. So I could conceivably get the 700s, and then supposedly I would get twice as much light out of the LEDs. Let's clip this on here. See how hot this is. It's barely warm. Oh, look at that, the amperage has gone down a little bit. Well, so far, so far. It seems to have stabilized at 90 degrees. I'm tempted to stick my finger over there to feel how hot it is, but I don't want any of that 275 nanometer light getting on my skin. volts. That's the current, otherwise called amperage. There's what's going into it. So far, so far. You know what I'm going to do? I'm going to try gradually dialing up the voltage to what it's going to be off the Makita batteries, which is 19.7. $13, 13.7, 14. You can see this is holding steady. That's holding steady. That's holding steady. This is actually going down a bit. $17. This is going down. The output amps is also going down. It's at 130 milliamps now. That rumbling you hear is the furnace turned on. At 18 volts now. This continues to drop when I raise the voltage. Here. And the output amperage is 120 milliamps. And this thing's decided to turn off. Let's not turn off. Alright, I'm going to go up to 19 now. Well, this is kind of interesting. The fluke has gone down to 348 milliamps. And the meter on this is at 11 or 1000 or 110 milliamps. And the temperature has gone up to 93. Well, that's kind of interesting. I guess I'll have to look at the this video later to see if the brightness has actually gone up on that from increasing the input voltage. I'm going to go to the full 19.7 now. Alright. That didn't seem to change anything else. Alright, I'm kind of liking this, man. No, not 1100, you idiot. 110 milliamps, 19.7 volts. And we're at 93.9 degrees in the heat sink. And these are steady. 348 milliamps and 5.71 volts. Well, this is encouraging. It's a lot more wire than is going to be in the actual unit, so I'm pretty sure I don't have to worry about having to add capacitors or anything into the line. Alright, this is good. Slowly rising, but these are staying steady. So it's going to be 8 of these going through this plug to 8 separate LEDs. I got to replace the mirror here. Never really polished up right, and it's very easily dulled out. So just the wrong aluminum. So I've got some 70-75 aluminum here to replace it with. All right. Okay.